In this video, we'll be taking a look at surface area. So the first question is, what is surface area? You could say that surface area is the area of the surfaces. Now normally, using the term to define itself never works. This, I think, is the rare exception where it does actually have some value. So surface area is just taking a look at all the surfaces, which could be sometimes called all the sides or all the faces, and getting the area of all of them. Another way to think about it is it's like measuring the amount of wrapping paper needed to cover a solid figure. Let's take a look at some steps. So step 1, we want to figure out how many sides or faces a shape has and represent them with a diagram. Step 2, we want to show the area formulas for each different face. And then step 3, we'll calculate the areas and add them up to get the answer. There are 3 types of shapes that we'll find the surface area for in this video. They are prisms, pyramids, and cylinders. Let's take a look what they look like. Here's our prisms. Now a prism will have 2 identical bases, and the bases are connected by rectangles. Now the top prism that you can see, that's a rectangular prism, so you can have any side you want for a base. But the middle one, that's a hexagonal prism, because the top and the bottom are hexagons, those would be your bases, and they're connected by rectangles. Often we think of bases as being the bottom of something. That's not the case in the prism. In the prism, the base is whatever is not a rectangle. So the bottom prism is a triangular prism. And even though the triangles are kind of on the front and back, those are the bases for that prism, and they are connected by rectangles. Next up, we have pyramids. Pyramids have one base, which we use to name the pyramid, and they meet at a point on the top. And it's their sides that come to the point at the top are triangles. So our top one looks like a square-based pyramid, and the bottom one would be a pentagonal pyramid. Cylinders are kind of like prisms, except their bases are circles. So you have a circle on top, circle on bottom, and they are connected. Okay, let's take a look at a problem here. We're going to calculate the surface area of this rectangular prism. So our first step to find the surface area is to figure out what this shape is made out of. So let's just take a look at some measurements here. There's our 15 centimeters. There are other places in this diagram that have the same measurement. There they are. Likewise, we have 10 centimeters, would show up in 4 different places, and same with the 20. So this will help us when we have to label the different sides that we have. Let's start with the top and bottom that you can see highlighted in purple there. And let's add some missing measurements. So you can see the top is 10 by 15, and so is the bottom. And the way we want to write this is by actually showing that there's 2 of them and drawing a picture, little miniature diagram of that rectangle, and labeling it with the numbers we need to find its area. If we look at the back and the front, those are going to be 20 by 15, and there's 2 of them. Next up, we have the left and the right. Those are going to be 20 by 10. At this point, I could easily get sidetracked by this weird optical illusion that keeps happening with this prism. There's 2 lines that are not dotted on this drawing that should be, that kind of makes it mess with my mind. I don't know how you're doing, but I'm not going to get sidetracked. I might do a separate video of that, but let's move on to writing our area formulas now. So below each shape that we drew, we want to go ahead and write the area formula. For a rectangle, that's going to be base times height. So the first one, we're going to go ahead and write 15 by 10, and then finish it off 15 by 20 and 10 by 20. All right, after that, we just calculate and add all this stuff up. So we get 2 times 150 plus 2 times 300 plus 2 times 200, and go ahead and simplify that down. and our final answer is going to be 1300. Now, what kind of units are we going to use for surface area? Let's take a look at our first formula, which was 15 by 10. Technically, that's 15 centimeters by 10 centimeters. And when you multiply centimeters times centimeters, you get centimeters squared. So when we do surface area, our final answer will be in square units. So this would be 1300 square centimeters. Let's take a look at another one here. This one's going to be a little harder. We have a pentagonal prism. First, we have to understand what kind of sides do we have and how many are there. So if you look at the top and the bottom that was shaded, those are pentagons, and there's 2 of them. We would then have 5 rectangles. Now we know the dimensions for the rectangle. They're 14 by 8. But we still have to find the area of our pentagons. And this is a regular pentagon. It should have said that in the problem, but we're just going to assume on these problems that the pentagons and hexagons are all regular polygons. So we need to find the area of the regular polygon. This will be a review if you've watched all my videos. If not, you want some extra practice on this, I did a video just on finding the area of a regular polygon. So we start by going 180 times 5 minus 2 divided by 5. This will give us one angle of a regular pentagon. So we get 108 degrees. And there's the angle that is represented by the 108. Actually, all 5 angles are 108. We are actually going to find the area of one triangle that you can see highlighted on the bottom. So our next step is to take the 108 degrees, divide by 2, and that would give us 54 degrees. We're going to deal with the right triangle to find the height. Take the 14 and divide by 2 to get that bottom part. And we're going to use tangent of 54 degrees equals the height over 7, multiply by 7, and our height is 9.635. Our next step is to use that to find the area of the total triangle, not the right triangle, but the isosceles triangle. So that'd be 1/2 times 14 times 9.635. Now I've actually kept the entire decimal on my calculator to do this, so I will just keep it on the calculator the whole way to get the most exact answer. So when we do this, we get 67.443, and then we have to realize the pentagon is made up of 5 triangles, so we multiply by 5, and the area of our pentagon is 337.214. Now, I've run out of space, so I'm going to leave that answer and make some space for the rest of it. So now we'll go to our next step, which is to write our area formulas. For the pentagon, I basically did all that work. I'm just going to write the answer we got, 2 times the 337.214, plus 5 rectangles that have an area formula of 14 times 8. Now we just need to simplify these down, and our final answer is 1,234 and 427 thousandths centimeters square centimeters. All right, next up, we will look at finding the surface area of a pyramid. It's still the same idea. We just need the area of all the surfaces. So what does this thing have? On the bottom, it's got an equilateral triangle. All the sides are 6. And then it's got 3 more triangles, which we know the base is 6 and the height is 10. So we got to do some added work here to find the area of our equilateral triangle. If I split it into 2 parts on the bottom with the kind of 2 right triangles, we need to find that height. And if we look at our right triangle only, that's a 30, 60, 90 triangle. So I can just use my pattern there and get a height of 3 radical 3. Now, if you use SOHCAHTOA instead, you would get a decimal answer, and your answer would still be correct. I'm going to go ahead and use the 3 radical 3 for my height, and now I'm ready to write my equations for the area. So surface area is 1/2 times 6 times 3 radical 3 plus 3 triangles that are 1/2 times 6 times 10. Now we just need to simplify these down. That right there is my exact answer, 9 radical 3 plus 90 square centimeters. But if you put that in the calculator and change it to a decimal, you get 105.588 square centimeters. Our last shape is the surface area of a cylinder. So what makes a cylinder? Well, it's easy to see what the top and the bottom are. Top and bottom of this is two circles. What do we need to know about this? We need to know the radius of the circles, and we need to know the height, the distance between the two circles. And from there, we can start writing what kind of shape do we have. We have two circles, and then the question is, what is the rest of it? Do we know what the rest of it is? It's a rectangle. We know the height of the rectangle would be the h, but the question is, how long is the base of that rectangle? And I had a great idea for this, but unfortunately, my special effects budget has been completely cut. So I'm just going to have to show you a quick video off the internet, which, by the way, is actually a pretty cool website to see these shapes in action. So let's take a look at where the base comes from in this nice video here. And you can follow the link there and see some other stuff they have. I'll also put it in the video description. So this is showing you exactly where the base of that rectangle comes from. All right, so there's the magic behind the base. The base is actually the circumference of the circle. And we know circumference is 2 pi r. So that means the length of our base is 2 pi r for a cylinder. This would be two circles which have an area of pi r squared. And then we're going to go base times height, 2 pi r times the height. That is our formula for finding the surface area of a cylinder. Now, if you Google the formula for surface area of a cylinder, there's a way to algebraically manipulate what we have here and write something in a different way. Personally, I don't like that formula at all. What we have here matches our drawing, and you can see that it's coming from the two circles and the rectangle. So that's what I'll be using. Let's go ahead and try it on a problem now. All right, we have our two parts. We have a radius of 4 and a height of 6. We want to go ahead and draw what we have. Two circles with a radius of 4. The height of our rectangle is 6, and the base is 2 pi times 4. Next up, we write our formulas. 2 times pi times 4 squared for the circle, and then the rectangle would be 8 pi times 6. Now we just simplify those. 32 pi plus 48 pi, and we get 80 pi square feet. By the way, almost all the problems we deal with that deal with circles, it's really best to just keep your answer in terms of pi. That is the exact answer. If you want to put it into a decimal, you want to figure out where the pi key is on your calculator and use that. Time for practice problems. So when you see the problem, go ahead and pause the video and work it out on a separate piece of paper. And then you can hit play and check for your answer. Here's problem number 1. Okay, here is problem number 2. Now watch out on this one. That is a right triangle on the bottom. It is not an equilateral triangle. And go ahead and see what you can do on this. One thing I want to point out about this answer is there's a little extra math involved finding the base of the rectangle in the back of this figure. So you have to use the idea of the right triangle and Pythagorean theorem to go ahead and solve for the base, which is radical 72. But when we simplify this, watch what happens. Radical 36 times radical 2 is 6 radical 2. Look, this is an isosceles right triangle, which means it's a 45, 45, 90 triangle. So I didn't have to do Pythagorean theorem. I could have just used the pattern. We have sides of 6, 6, and 6 radical 2. And then that goes as our base, and then the rest looks like problems we've done. Problem number 3, the surface area of a pentagonal pyramid. You can save some time here when you realize that we already did a pentagonal prism. and it had sides of 14. So instead of doing all the work on this problem, you can use the work from your previous problem to figure out the area of the base. Go ahead and give it a try. And here's your answer. All right, last problem, surface area of the cylinder. And check your answer.